This is the introduction to section 10.2, part 1, where in 10.2 part 1 we're going to talk about the area of trapezoids. Part 2 we'll talk about the kites and the rhombuses. But for part 1 we're going to talk about finding the area of trapezoids. So, you can find the area of a trapezoid when you know its height and the length of its bases. Now, the height of the trapezoid is always the perpendicular distance between the bases. Now, as you look at this picture here, okay, so to find the area of the trapezoid, we're going to take 1/2 times the height, and then take that times the adding of the bases. Now, I'm going to have you put this in your notes as well, because I'm going to rewrite this. This is really height times base 1 plus base 2 divided by 2, if you want to rewrite it that way. So for some of you who don't like the 1/2 in front, that will help you out a little bit. Now, in the case of the height, not every time are they going to give you a height. There are going to be some times where you're going to have to find them. And you'll see an example of that here in just a second. Okay, so to find the area of a trapezoid, we've got height times base 1 plus base 2 divided by 2. Okay, first example, it says here, what's the approximate area of Nevada? We'll round everything to the nearest tenth in this case. So, as you look at this, and you look at the label, you see that this trapezoid's on its top, or on its side essentially. So we would count this again as base 1, this is base 2, and you would count this part as the height. So again, when we plug this into the formula, height times base 1 plus base 2 divided by 2, the height is 309. When I add the two bases together of 205 and 511, I end up with 716, and then we're going to divide that by 2. Well, if I take 716 times 309, I end up with 221,244, and we're going to divide that by 2. And again, if I divide that by 2, I end up with 110,622, and my units, since it's miles, will be square miles or miles squared. So the approximate area of Nevada is 110,622 square miles or miles squared. Okay, what is the area of trapezoid PQRS? Now you'll notice on PQRS that we've got, here is base 1, here's base 2. Again, it doesn't matter which one you choose as base 1 and 2. Simply because, again, you're going to add them together, so it doesn't really matter. Now, the one thing that you see is missing on this one is the height. And the height is this line from S perpendicular to PQ. And you'll notice they don't give us a side length here for RQ, which would be the same as that line. Unfortunately, they don't give that to us. But they do give us that we have a 30, 60, 90, because it's saying this is 60, and that's 30. Well, I know in this case, if that's, this side right here is 5, okay? And if that's 5, then that means this bottom part is 2. So this side length right here is 2. And now it's going to have to jog the memory a little bit of a 30, 60, 90 triangle. Okay? On a 30, 60, 90 triangle, you got the short leg, the long leg, and the hypotenuse. Well, remember, in this case, this is the short leg. The long leg is the short leg times the square root of 3. So the height here is 2 square root 3. Okay, that's the part that we need to know. So, when I plug this in now to find the area, height times base 1 plus base 2 divided by 2. The height is 2 times the square root of 3 times, if I add the two bases together, that's 5 and 7. And then we're going to divide that by 2. Well, a couple things about this is that I know my 2's will cancel because they're both on the outside. So this is really the square root of 3 times 7 and 5 is 12. So I really know that this is 12. The area here is 12 times the square root of 3 meters squared. Now, if you actually went through and calculated the number for that, 12 times the square root of 3 is, if I round to the nearest tenth, 20.8 meters squared. Okay, so this is the case, this is an example of a problem where I give you a trapezoid where they don't give you the height and you have to find it. Now the question is probably going to be asked, will it always be a 30, 60, 90 triangle? Not necessarily. It could be a 45, 45, 90 triangle. But either way, you may have to use some regular trig there as well. I may not give you the angle measure. I may say it's 52 degrees, where you might have to use some trig. So it's going to have to bring back the memory a little bit of using the trig functions. Okay, so this concludes section 10.2, part 1, where we are finding the areas of trapezoids. Don't forget to complete your WSQ.